Welcome to the Achronix Speedcore Validation Platform demonstration. Achronix's Speedcore eFPGA technology is IP that opens new opportunities for companies looking to integrate embedded FPGA technology into their ASIC or SoC. Speedcore is a high-performance, fully permutable architecture allowing customers to define the amount of logic, memory, DSP, and their own custom blocks to fit their application requirements. Today, we will demonstrate a validation platform for the Achronix Speedcore embedded FPGA IP technology. This platform includes Achronix's ACE design tools, which support this Speedcore instance, a test characterization board with Achronix's 16nm Speedcore silicon validation device, and a demonstration design running on the device, highlighting some of the Speedcore capabilities. The silicon validation device is fabricated on TSMC's 16nm FinFET Plus GL process and has a high-performance Speedcore eFPGA core with 40,000 lookup tables, 48 20K-bit block RAMs, and 72 DSP64 blocks. Along with the validation board, we are also using a white noise generator that will produce an input signal, an analog to digital converter module, a digital to analog converter module, and a spectrum analyzer to visualize the output of the design. The digitized signals are transported into and out of the silicon validation device over 12-bit LVDS buses at 500 megasamples per second. The 500 MHz clocks for the data converters are derived from the main 500 MHz Speedcore input clock, which is generated by the onboard clock generator. In this demo design, we have implemented several built-in signal generators and 2 blocks of finite impulse response filters, which have selectable coefficients. We can forward the filter outputs to the D to A converter either individually or as a sum of the 2 filter outputs. We have the hardware set up on this bench with the validation board and data converters in the center. We are using the laptop to control the design and will display the demo on the monitor on the right. We have loaded the design into Flash, so when we power up the board, the design is running instantly. We will control the operation of the design from this panel in the ACE design tools, which writes to control registers in the silicon validation device. Here, we use the internal signal generator to produce a square wave derived from a counter in Speedcore. This produces a square wave toggling at the clock rate, which will show 250 MHz or 500 megasamples per second. Next, we select the ADC input fed by the white noise generator and set the filter block in pass-through mode so we can observe the input signal passed through the Speedcore. We see a flat amplitude across the spectrum. We will save this as a reference trace shown as a blue trace on the analyzer display. Next, we can switch from bypass mode to filter mode. The filter in this design is a 71-tap finite impulse response bandpass filter operating on 12-bit data with 27-bit coefficients. The filter has 4 selectable coefficient sets and can filter bands at 25, 75, 125, and 175 MHz. When we activate the 25 MHz filter, we observe a passband centered at 25 MHz, with narrow transition bands and more than 30 dB rejection of out-of-band frequencies. Next, we will switch to the other filter block at a different frequency, again showing nearly identical filter characteristics. Now we can view the sum of the 2 filter outputs as we cycle each filter through the 4 coefficient selections. Turning on the history mode on the spectrum analyzer allows us to see the filter performance over time. This concludes the demonstration of the Achronix 16nm Speedcore silicon validation platform, including the functional capabilities of this version of Speedcore. For more information about Speedcore, contact Achronix by sending an email to sales@achronix.com.